The third assumption is the data that will be used in the procedure in the process of t-test must follow the normal distribution. This is very important assumption. Dear audience, we know that in testing of hypothesis, each test has a specific formula known as the test statistic. We can also say it the estimator. And this formula, this estimator, this statistic follows some specific distribution. And another concept is that the p-value that can be used for the decision of rejection and acceptance of null hypothesis must be calculated from the same distribution to which the test statistic follow. Here in t-test, in the case of t-test, the statistic follow the t distribution, but this statistic follow the t distribution only if the data comes from the normal distribution, and if the data comes from another distribution, the statistic of t-test will not follow the t distribution. And think about it kindly. If the statistic does not follow t distribution and we are calculating the p-value from t distribution for decision, then what will be about the results? The results will be contradictory. That's why we can say that the normally distributed data must be used in applying the t-test. The fourth assumption is there should be not the outliers, the extreme values in the data, because if the data consists of outliers or extreme values, it will not follow the normal distribution. Now, step 2 is going on. If the normality assumption has been violated, then what will be done? Here is a graph before you people. If the normality assumption has been fulfilled, then you can easily apply the t-test, and if this assumption has not been fulfilled, then you must choose one of the two solutions. First is apply any transformation to your data and make it normally distributed, and then apply the t-test. And second option is you will go towards the non-parametric tests. In transformations, you can apply the power transformation or log transformation. And as an alternate of t-test in non-parametric, you can apply Wilcoxon-Mann-Whitney U-test. Now go towards step 3. Here we will learn that how to apply both the paired and unpaired t-test in SPSS. Before this, you will follow a specific procedure for your articles, for your thesis, or for your projects. The procedure is, first you must write the hypothesis for t-test. H0, the null hypothesis is the two groups are same on mean, the two groups are same on average. And the alternate hypothesis is the two groups are not same on mean. You can modify these statements according to your field of study, according to your research, according to your projects. Second, go towards the software SPSS or MS Excel, etc. and apply the two sample t-test and get the p-value. On the basis of this p-value, you can decide whether the null hypothesis has been rejected or not. If this p-value is less than 0.05, then you should reject the null hypothesis. A little definition, a little description about p-value is given here. P-value is the probability in favor of H0. If this p-value is as small as less than 0.05, then H0 being less favored, you must reject it, because the p-value is saying the favor towards H0 is very small, so it should be rejected. Here I have applied some normality test to our data that will be used here in this video to apply the two sample t-test. We have applied the Kolmogorov-Smirnov test, Anderson-Darling test, and chi-square test of goodness of fate. For all these tests, our data follow the normal distribution. Now go towards SPSS. First, I will tell you how to import data by different methods in SPSS. Firstly, you can click on File, on Open, on Data, and import data from your Excel file to SPSS. First, we apply the paired t-test. Open the data. Click on OK. Here is data before us. We have two basic columns, pre-module score and post-module score. Definitely for this type of data we must apply the paired sample t-test. Now go towards the second method of importing data into SPSS. First, you have to open an empty file of SPSS, then click on the cell of first row and first column, then go towards your Excel file and copy your data by clicking Ctrl C, and in SPSS file click on Edit, then click on an option Paste with variable names. Your data will be imported in SPSS. There are two basic methods to import the data in SPSS. Now we apply the paired sample t-test here. So go to the option Analyze. First click on Analyze, click on Compare Means, then click on Paired Sample t-test. Here a dialog box will be opened before you. Pair 1 and variable 1, variable 2. So select the variable 1 and put the first variable, means pre-module score, in this option. Then the post-module score will be imported to the second variable. Then you will click on OK and get the results of paired 2 sample t-test. The results are before you people. These are the results. Paired sample statistics, these are some descriptive measures before you. Paired sample correlation, this is about the correlation of two samples, and here is the p-value of our 2 sample t-test. Keep in mind, remember please, our null hypothesis was the situation was same before applying the module and after applying the module, and H1, the alternative hypothesis, was the situation was different before and after applying the module. So according to this p-value, our null hypothesis has been rejected because this p-value is very less than 0.05. This p-value is very small. It means that from this p-value, H0 is being very less favored, so it should be rejected. And according to this result, according to this decision, you can write a comprehensive report according to your subject area, according to your study. You can write why the null hypothesis has been rejected, what was the main reason, what was the circumstances behind this. This was due to that reason. This is only connected with your field of study, and a comprehensive report can be written easily. Dear audience, I am now going to apply the independent t-test, the unpaired t-test before you. So go towards the Excel file and import the data. Click on Open Data. I am going to import the Excel file. Here is an Excel file of unpaired t-test. I will import the data by clicking on OK. This is the data of independent or unpaired t-test. For independent t-test, for the comparison of two groups, here are two fertilizers are being compared. We write the first column of the names of groups, labels of groups will be written in first column, and the data will be written in the second column, because the yield, the data, is the dependent variable, and the factor, that is fertilizer, is the independent variable in applying the two sample independent t-test. Then go towards analyze, click on compare means, then on independent sample t-test. Now in the box of test variable you will put the yield, you will put the column of your data, not the column of labels. And in the box of grouping variable you will put the column of labels, the column of names. You can define groups here. We can define the first group as A and the second group as B, or you can write the complete names of fertilizers. Then click on OK. You have the results before you of independent t-test. These are some basic statistics. This is the p-value for independent t-test. According to this p-value, our null hypothesis is both the fertilizers are performing same on average yield, and H1 is both the fertilizers are performing different on average yield. So what is this p-value saying? According to this p-value, our null hypothesis has not been rejected, it has been accepted, because this p-value is very large. This is greater than 0.05. So according to this p-value, we have accepted our null hypothesis. Dear audience, these are the procedures for independent and dependent t-tests. Kindly, for other tests, analysis of variance and multiple comparison tests, keep on watching my videos in my playlist on YouTube. Thank you very much.